Chapter 3 is going to be on prenatal development. There's not a whole lot on your test when it comes to this slide in particular, but I would definitely know that mitosis is how our cells divide within our body. Every one of our cells has 46 chromosomes that make us uniquely different. And so we get 23 of those from our mother and 23 of those from our father. And so the cell division that occurs, though, in sex cells is going to be called a gamete. So a sperm or an ovum or an egg, those are gametes. That is on the test. They don't really go into a whole lot of other stuff on this, except that know that the sperm actually have 22 chromosomes, and then the last chromosome that makes up the 23rd is either going to be an X or a Y chromosome, and that determines sex, whether you're going to be a boy or a girl. So if you get, if it's a Y chromosome, then they're going to have a boy. If it's an X chromosome, they're going to have a girl. Fertilization usually takes place takes place in the outer 1/3 of the fallopian tube, so the area that's closest to the ovary. It was going to be fertilized, and you can see where it says spermatozoa on your left, right above the little north, south, east, west compass sign. You can see that's where the sperm's actually meeting the egg, and then it begins its division until it gets down into the uterus and it makes implantation. Just some slides of early changes of cells. So thing to remember on this one is that when an egg makes it down to the uterus, and we've got this little, it looks like a little shrimp over here on the left, upper left, it says amniotic cavity, so there's just a little bit of fluid probably around that, but then you see this big yolk sac thing on there. That's what's going to sustain that that fetus, or that tiny little ball of cells, until this, where it says chorionic villus. Those are the tiny little capillaries, basically arterioles and venals, that are going to establish into the endometrium and create the placenta. So until those become functioning, that yolk sac is going to provide all the nourishment that little egg needs there. And eventually it'll just end up being reabsorbed. I mean, you can see to the next side where it says yolk sac, it's started to deflate a little bit, but you can see how much bigger the cells are getting, and how many more of these little finger-like projections. It kind of looks like little tiny tree roots to me. And then it gives you down here, it says, 3 weeks, this is about how big it is, 5 weeks, and then 4 months. Some more pictures of development. And the interesting thing is, you're not the top left, but the top right. Pretty much every mammal, whenever they're at this stage, looks exactly the same. If they have a spine, brain, lungs, all that stuff, that whenever the little arm and leg buds start to develop, puppies look like this, kittens look like this, humans look like this. We all start off looking like that, and then, of course, we become very specialized. This is what a placenta looks like after delivery. The one on the left is really, really beefy looking. That is the side that was attached to the mother. And then the shiny side that you see on the right, that's the side that baby was next to baby. Umbilical cords, know that they have one vein and 2 arteries, and the vein is the one that carries all the oxygen. If you ever have to do a cord gas for a doctor, you always have to get a venous and arterial blood. You always draw the venous first, you draw the artery first and then the venous last. Because if you draw the vein first, then the 2 little arteries up there are going to end up collapsing, and you can't get that blood after that. The one on the lower left is what's called a true knot, and basically while the baby was in utero, it is moving around and doing all this stuff, and if they have a really long cord, they're more susceptible to this. But they twist and twist, and they tie their own cord into knots. And I've had one patient who had a true cord times 4. And that was probably the longest umbilical cord I've ever seen. The top one, you can see where, the top left, you can see where they've got it clamped pretty close to the baby's skin, and then you can see the rest of the umbilical cord hanging down there. It is very white and clean looking. They've wiped that one off, obviously. You can see the big, nice, juicy vein in there, and then everything else, it's very, it's kind of like a garden. It's very thick, and it's difficult to cut. So it's tougher than everybody thinks it is, but it's full of this stuff called Wharton's jelly, and that Wharton's jelly, all it does is support those veins, that vein and those arteries, and provide cushioning for them. So here's placental circulation. Always know that mom's blood and baby's blood never, ever cross over to each other. So that's why babies can have a completely different blood type, and we'll get into RH factors on another chapter, but know that if everything's going normally, maternal blood and fetal blood never cross. But these little arterioles, these little chronic villi, and the maternal venal and the maternal arterial, they are so thin that they're able to, through osmosis, they're going to pass back and forth waste and oxygen, and that's how that works. Fetal circulation again. We're going to talk about shunts. So the ductus venosus, and the way I kind of remember ductus venosus is, when I think of venosus, I think, of quite a bit of blood, and we know that that the liver is responsible for the liver is going to be responsible for filtering all that blood. But in a baby, the liver is very immature. It's not really functioning that well at that moment. And mom's body is doing all the filtering for it. So it doesn't really need to have the liver functioning at that moment. And so what happens is we get this this little shunt. You can see where the arrow is pointing at, and it prevents the blood from going into the liver, and instead it takes it directly to the vena cava. So we're just bypassing organs that are immature, and there's not a need for them while they're in utero. So the foramen ovale, you can see where the arrow is pointing right there, and it almost looks like another little valve or something. But it's a shunt, and it's shunting blood between the right and the left atria. And the reason why it does this, why are we shunting? Because this one is keeping the blood from going to the lungs. Now, babies do practice breathe with their lungs, but they're breathing in and out amniotic fluid. So there's really, until we get to the point where we need to be breathing on our own, then we can just bypass the lungs, and that's what that shunt is there. The ductus arteriosus, that's going to be the shunt between the pulmonary artery and the aorta. And I cannot get let me see if I can get my pen to work here. So, oops, go back. Where's my pen? Sorry, guys. Okay. So if we look right over, well, it's still not working. If you look, you can see the difference in the two pictures where the aortic arch is, and then this one's got this over here's got the shunt. And it's also, just know that the two shunts on the heart are shunting blood away from the lungs. That's their primary reason for them being there. And then also, going back to that real quick on these shunts, that once a baby takes that first breath, then both of those shunts should close fairly quickly after that. I mean, like within minutes, those two shunts will completely close off, and the lungs are functioning and able to provide oxygen for the heart. Twins, we know there's either monozygotic, meaning it comes from the same egg, and those are identical twins. And then dizygotic are from two different eggs. So just know that. Excuse me. This just goes into the breakdown of how they divide and how many days and so forth. That's it. That's the end of 3.